For HP Cloud Services, so for those of you that don't know quite where that fits into the whole hierarchy of HP Cloud Services is the public cloud part of HP, so we're providing the public cloud side of that. Before I talk, I did just want to say a quick thank you to Canonical for hosting us tonight and providing the venue, and especially the beer and the pizza. When I first posted to the group saying, wouldn't it be a good idea if we had a UK meetup, I was kind of feeling I'd have to do a bit more of the organising to make it happen. And Mark said, yeah, that's a great idea, and we'll do it, and we'll do it here, and we'll host it, and we'll have it on this date. And it was like, wow, that's brilliant. It's like, you know, it's like submitting a blueprint into OpenStack and finding somebody's implemented it for you, but that doesn't do anything. So thanks a lot, guys, for hosting it, and it's been great. It's really good to. So I'm going to talk a little bit about some of our experiences of running OpenStack at scale, and just give you some pointers of some of the things you need to look for if you're starting to stand this thing up at something, you know, bigger than a few tens of boxes where you're running, some ideas to look out for. But before I do that, I want to understand where we came from. So HP's sort of journey into this, back in 2011 in March was when we announced our cloud strategy. Although, to be honest, it was probably the second or third time we announced our cloud strategy, but this was the time when we announced our cloud strategy that really included public cloud and set out our stack as to what we were going to do in terms of being a public cloud provider. So the strategy that HP has is about a lot more than just our public cloud, and OpenStack is a much bigger part of that strategy. As we're looking to do, we stand up a whole bunch of private clouds for people, we look to a hybrid model, but this was really when we crystallized, particularly where we saw the public cloud offering fitting in. And then in July, we joined the OpenStack community and made it clear that we were going to take it and we were going to go to market on the back of OpenStack. And I'll explain a little bit more just why we saw OpenStack as the big thing. By September, we'd got our private beta up and running across all of our services. Loads of people sign up. We were running on our own hardware. Clue there. One of the things we've done, as well as just having the OpenStack software there, is we have a whole bunch of people, and Dave was saying he goes through our portal quite a lot to use stuff. As well as the portal, we've also got available a number of language bindings for developers, because getting developers, you know, making this a good platform for developers to work with is a key part of where we see the market going. So there are bindings that you can get for us that work with OpenStack, for Ruby, for Java. There's a Windows binding that runs on there as well. If you go to the portal, you can get access to those. And then in May this year, we took it to public beta. So no longer was this, you know, by invitation only. Anybody can sign up, and there are always offers on there all the time. We're in private beta for coming along, joining in, and starting to use it. And it's kind of grown from there. And in fact, if anything, it's moved slightly on now because we've now just taken the first of our service through into general availability, so beyond the private beta stage. In terms of where we went to OpenStack, there are a number of kind of reasons. The one I'd really pull out was the open API aspect. So one of the things that's really important, you know, the API defines what the experience is of coming to use a cloud. And if you're trying to work to a model where you want people to be able to run their own cloud, come to your cloud, you want platform providers to be able to choose where they're going to, the API is the thing that really defines the experience of that. And for us, it's very important to be in an ecosystem where when you have a really good idea for something you want to provide for people, you can add it as part of an extension to the API mechanism. And that's what you get with being with OpenStack. You know, we can say, okay, either you submit it, OpenStack has an extension mechanism for its API, and we think that's really important in letting the kind of innovation from people working together come into these things. I'm not knocking EC2 API, it's a great API, there's loads of people use it, it's great that OpenStack supports it, but it's quite difficult if you're constrained by one body that's controlling that. So this was a big driver for us in seeing OpenStack as being one of the things that made a lot of sense. Obviously the ecosystem and the community, anybody that's been to any of the conferences or follows the stuff can see the sheer amount of knowledge and interest and buzz there is around those things has been great. And it's you know, we are actively involved on the governance boards. We're very heavily involved in setting up the OpenStack Foundation and the design summits, and we're always up for helping with beer and pizza when there are good events on. In terms of what we have at the end of that then, so these are the kind of 6 main services. We've got a bunch of other things, but we also have a cloud service, a compute service. You can't really be in a cloud without a compute service. We have object source, this is Nova. As Dave was explaining it, this is Swift, and a content distribution network on the back of that, so that if you're using it, you get your access to your content locally. These are the 2 services that have just gone to GA. GA means that they're backed up by an SLA as well, so they're a full kind of commercial service. Public beta means it's available. It's not running yet to a published SLA, but it's still there, and you know, anyone can sign up and anybody can use it. So we have our compute, our identity service, which is Keystone-like. Obviously, it supports all the things you need for getting in, but there's a lot of other facilities we've got in there. And we've got two other items that are currently in private beta. One is block storage. So this lets you build persistent volumes and manage volumes inside your compute engine. And we also have a database as a service offering that's there, that's also currently running in private beta, that's kind of layered on top of those as we go into the public space. So it's been quite a journey over the year to get to the point of announcing strategy, saying we're working with OpenStack, standing these things up and getting those things through. And we're hiring. Right? So anybody that wants to come and live life at the edge, then feel free to be in touch. Okay, so aware that I sit between you and a lightning talk and beer and pizza. So I'm not going to give you hundreds of slides, but some points of things that certainly we've learned in trying to run any system at scale, but particularly in trying to stand up Nova at scale, which is particularly where I sit. I'm the technical lead for the compute service. So the very first thing you have to do, if you're going to start to build a system at large scale, you've really got to be worried about the consistency of the build and the deployment that you're going to do for the base platform. This isn't something that's really particular to OpenStack. Anything that you're building at scale, whether it's some sort of HPC system, a large Hadoop cluster, or anything like that, being able to reliably build hundreds of servers to the same build and know they're at the same build and maintain them at the same build is absolute core. So the reason I call it out is it's one of those things that I've found from past experience. It's easy to miss a trick if you start small and gradually grow to be bigger, if you haven't sorted out the bedrock for these things first. So if you're looking to stand up something at significant scale, then you really need to consider how you're going to get that base platform there, maintain it, maintain the configuration, and also how you're going to operate it and run through rolling changes and to do those things. So very hard to retrofit that. So if you're aiming into this space, make sure you pay attention to that. So you're looking at deployment tools, using something like Chef to get a consistent deployment out there. You need something for imaging the machines. You also, obviously, in the same way, you need to think about how you're going to operate it and how you're going to manage these things. Once you start to get hundreds of machines that are talking to you with log files, then going and looking at log files and even aggregating log files isn't really a great way to run things. One of the things that's developed quite well through Nova over the last couple of releases is the notification system, which uses a separate, you can actually configure it to drive a number of ways, but there are a number of points in the code now where notification events are generated. Originally it started largely as a way of getting key information, usage information out for billing. It's recently kind of taken on a bit more of a life of really becoming a kind of management framework, so that it uses the same message queue architecture that Nova uses to communicate with each other as a way of giving you feedback for key events that are going on in the system. There is some work in a kind of incubator project to provide things that can now hook on the back of that that's moving towards more of a metering system, but the basic framework is there, so it's quite a good point to understand and be able to get a view into the system saying, okay, well, what's happened for this particular user, or what's happened on this particular server? But as with anything building at scale, you do need to think about what you're going to do just operationally. And then in terms of the technology, if you take the kind of big issues, the big parts of the system, so the database, people have mentioned this, and I don't know how many people know OpenStack architecture, but particularly in Nova, there are two kind of main central components apart from the sort of worker bees, the compute nodes. There's a database where all the persistent state of the control plane is maintained, and there's a message queue that's used largely for things to communicate with each other. Nothing particularly magic here. It's a MySQL server. It's not a particularly big database in terms of what you might do if you were standing up a database service. But one of the things that's slightly bizarre about the community is there's a strange reluctance, although the database self-configures and the schema self-configures, there's been a very strange reluctance to actually put any indexes on it as part of the out-of-the-box install. And there have been a number of attempts for people to submit things saying, wouldn't it be a good idea if we put these indexes in? And there's been, the great thing about working in the community is there are hundreds of people that contribute, right? The bad thing is there are hundreds of people with ideas on what is and isn't a good thing to do. And it's sometimes the logic doesn't necessarily follow the way you would think. So one thing you do need to look at, once you start to stand up at any kind of scale, is to look at the database and do some work to put some indexes on there. Some of them are fairly obvious. If you look at the instance table, which is the nub of the system, there are really two things that look at it. Compute hosts look at it to find out what instances belong to them. So you need an index on the host where they're running. Customers are querying it all the time to find out what their instances are doing. You need an index on where the project ID. There is a bug. If you look at the bugs that are currently open, there is a bug on there raised saying there are no indexes, and there is a bunch of information in there that's contributed by rack space, and also some things that we found that is the list of things that we're saying really should be indexed. And we're hoping that we can get to the point where we can agree that these things really ought to be there stood up. But just as a, as a pointer, once you start to look up, you'll need to pay some attention to that. The other thing about the database is that although you need the indexes for performance, you also need to work out what your archiving strategy is going to be for some of that database content. So the database contains a number of things. It contains tables that are in effect almost virtual resources, like the list of IPs that you're going to allocate out to machines. Those tables don't change much over time, at least the entries, the contents of them is fairly, in terms of rows, is fairly static. But there are a number of other tables that are much more temporal in nature. So where customers have defined and got the system to build SSH keys for them, for example, or have defined security group rules, which is the kind of firewalling rules that you have for your VMs. And even the instances themselves, these are things that just all become rows in the tables with relationships. And one of the things that Nova does at the moment is it will, in some cases it will tidy up rows, but in most cases when it's finished with something, it will just set the deleted bit on it in the database. And that's kind of quite good up to a point, because you can go back and, when you're coming to look to see what's happened, you can go back and look into it. But it doesn't have any capability built in to actually ever clear those things out. Now, if you start running at scale, not only have you got lots of machines, but you've also got quite a high churn of VMs going through. And you may find this even at a smaller scale if you're doing quite aggressive testing and you're continually trying to exercise the control plane. Those tables can get quite big quite quickly. And that coupled, sort of exacerbates the indexing issue, right? Because suddenly you've got things that are trying to do full table scans when really they don't need to. But also you need to think about what your archiving strategy is going to be. And it's not necessarily just as simple as clearing out things that are marked as deleted. You've got to make sure that, first of all, you're trying to keep some kind of referential integrity across those. But you also need to consider what your own, especially if you're going into the public space, what your own archiving requirements are and the legal requirements are for retention of data, etc. So just highlight them as areas that you need to look about in the database. The database itself, give it enough tin, give it some good reliable server hardware, runs pretty solidly. The message queue server is another component that, as a technology, we use RabbitMQ, runs solidly, it's able to cope with loads and loads of connections. As you start to scale the system up, the only thing we found in that space that you need to keep an eye on is you do need to make sure it has plenty of open file descriptors. Nova isn't really a messaging system. It's really an RPC-based system that happens to layer it on top of a message queue. So in some cases it uses messages asynchronously. But in lots of cases it uses pairs of messages to kind of emulate an RPC call. And what you find is that each RPC call will take another pair of connections, because there'll be new queues that are implemented. Each call that's going out will take another connection. So you can quite quickly, if you've got hundreds of nodes, end up using thousands and thousands of file connectors onto the MQ. Good news is the server will cope with it quite happily, and the kernels are quite good at supporting large numbers of those, but you just need to kind of watch for it for not hitting problems. In terms of really growing out the system, one of the things that seems to be fairly consistently a limitation, and perhaps a non-intuitive one, is that the physical network that you're connecting this thing to will quite often impose a bunch of limits on what you can do that are really nothing to do with the Nova software. So in particular, if you're starting to run thousands and thousands of VMs and you're running them on a flat network and they've all got to push their own MAC addresses out there, then the ARP cache table sizes in things like the switches become a limiting factor, probably before any of the infrastructure components do. Now, it's one of those strange things. There's been lots of effort and lots of talks at most design summits to say, what can we do to get rid of MQ and go to zero MQ? What can we do to have a no database solution? But actually, realistically, those things at the moment aren't proven to be scalability limits in building the systems. That physical network architecture has been one of the things that tends to constrain the size of a Nova instance that you can put together. So you certainly need to, if you're coming into it purely from an IT and a server perspective, you may well need to have a good sit down and talk to your network engineers about quite what you want to do in that space. Some of this is alleviated as you move out of the things that are being in Nova into Quantum, which is doing more of a level 2 type management. But it's only been networking. I think whenever you hear anybody talking, the bit that causes most problems in Nova, the bit that's probably the hardest part of the code, where most of the complexities come in, is in the network setup and in the network code and in the physical network. We've probably had to debug more issues in that space than we ever have in things just to do with virtualization, which is reasonably well-trodden code and reasonably well-understood stuff. Glance is another area that you need to think about at scale. So Glance is the image server. It's a separate project, and it's moving to the point of having its own public API, because obviously you want users to be able to load their own images to run in their VMs as well as images that we provide. And it's quite easy to think that you'll stand up hundreds and hundreds of servers and forget that actually you also need to scale up that image infrastructure at the same time. And it depends a lot on what your workload is. And you know, that kind of varies, I guess, depending where you are in the market, because the Nova control plane, the nice isolation thing is that once the VMs are running, Nova's really got very little to do with them. You know, it's nicely isolated as a control plane. So if people are launching VMs and they are generally fairly long-lived, so actually the majority of your work is just in running and processing stuff, then you can probably get away with a reasonably small control plane. If you're expecting to crunch through, you know, a high churn rate around the VMs, you're going to be creating and deleting things all the time, you're going to be creating loads of snapshots of your VMs and downloading them, then the Glance server itself can become quite a bottleneck. Now you can scale it, you can put multiple, it has a kind of, it's a two-tier architecture, you can scale out APIs on it, but it's just one of those things you need to think about doing. We have recently contributed a patch back into Glance that gives a major performance boost into the kind of code that lives on the SQL engine at the back end of this as well, because there were some things in there that really weren't kind of as well threaded as they needed to be. So watch out for that. The API servers at the front end, one of the issues we hit was the change is now being contributed into Foursome 2. We tried to work with the guy doing it to get it into Essex, but it didn't quite match it. The API server, if you currently download anything other than Foursome 2, is essentially a single-threaded API server. Now again, if you're not cranking loads of things through the control plane, you can probably run multiples of those, and it's horizontally scalable, but it's quite hard to exploit the full power of the box. The code we worked with, and we contributed back to the guy that works for Intel, is now actually turns that into a proper multi-processing API server, so you can exploit all those cores that you buy from us on your servers and run you know, huge amounts of API work in there. So that's good, and that's, as I say, that's just landed in Foursome 2. The other thing you need to look at, again, depends on your use case. If you're building clouds internally, maybe you don't care. As a public provider, rate limiting what people are doing to provide some level of protection against, you know, attacks is fairly important. The rate limiting that's in Nova by general acclaim is not all that great. The code hasn't really moved on very much probably from the cactus stage, and it pretty much is built around, it only works on the OpenStack interface, and it only really works on the context of a single process, and you can't really configure it very dynamically. So it's kind of okay if you're getting started and you can live with some constraints, but it's really not going to fit with what you need to do. We worked with a guy called Kevin from Rackspace, has got a plugin that's not part of core OpenStack, a thing called Nova Limits, which is built on turn on another product called Turnstile, which seems to work reasonably well for doing API rate limiting. It's backed up by a Redis database. And we've taken that and we've contributed some stuff back to make it work with the multiprocessor model, and also to work on the EC2 interface, because the default OpenStack one limits you on kind of URL and HTTP verb, which works great for the REST interface for APIs for OpenStack. The EC2 interface clearly uses the same protocol. It uses push everything, and it's just based on the action, so you can't really easily extend it. So we've got an EC2 adapter. But a lot of people are looking also to do, you might well be, depending on the breadth of your offering, you might well do this up at the network layer or in some other layer, but just a word of where to look. And then the last point is, this applies, I suppose, particularly to the developer community, but also you need to look for some of the configurations here. So inside Nova, there are kind of two loads that go on. There's the load that happens because somebody has requested something from the API. Right? There's a transaction going through the system, going across the message queue and making something happen. But there is also a lot of stuff that just gets triggered periodically inside each of these components. Inside a compute manager, inside a network manager, there's now periodic tasks in the scheduler. And these do certain amounts of housekeeping. Inside the compute manager, for example, it's continually updating the state of what the hypervisor is reporting against the state of what Nova thinks VMs are at. And that's all goodness, but you have to be quite careful when you're trying to extend that model. If you've got hundreds of nodes and you add what looks like a fairly simple periodic task, you can suddenly find that you actually get a sort of an event storm hitting your database if what you've done hasn't been coded very well. And there are tasks, as people have found more and more things to do, a few more things have crept into that space. There's code in there now, for example, that does regular checks of the downloaded images to see whether they're still needed. Those things will go to Glance to see whether the image is really still in the good state. So at scale, you need to start thinking about whether the default settings for those things, which tend to run things fairly often, are actually what you really need to live with. And particularly if you're contributing stuff back in this area, you need to be quite careful to say, okay, how often does this really need to run? And if it's going to iterate over a lot of things, so a periodic task, one of the performance issues that we hit that we pushed back into Essex, got in Diablo to go in Essex, was this task that goes through and looks at the state from libvirt and does an update. It seems fairly innocuous. But when you start stacking a lot of VMs up on a machine, it can take it quite a while to go through and actually do all of that work. And the threading model in Nova isn't all that great. It's based on eventlets, on green threads. So a periodic task that takes a long time can then start to block a whole bunch of other things that you may be needed, including the thing that's told the scheduler whether the node is up and running. So you do need to look quite carefully if you're into that space and have those kind of considerations and build in yield points to say, it's great, I want to run this, I want to run it every 5 minutes, but I'll at least give a chance for other things to run when they're running through. So I didn't want to dump you with slides. So those are my kind of top tips. If you're looking to start to stand something up at a bigger scale, certainly bear these kind of things in mind. And then finally, I just wanted to call out some blueprints in Folsom that I think are quite interesting in this space. We're currently partway through Folsom. Folsom 2 is available to download. We're kind of, I guess, a third of the way into Folsom 3. And then the final one will be more of a bug fix thing. So there are a bunch of blueprints that are still open. Some will land, some won't. That's the excitement of working in a community. But some that are quite interesting. There's an architecture called cells. And the blueprint for this is actually registered on Essex, because that's where the first part of the implementation came. But there is a bunch more work being done. And cells is really a kind of an aggregation framework that the Rackspace guys have developed for putting multiple Nova instances together. So the architecture is effectively at the top level, you kind of have an API server and a scheduler of sorts, and an aggregated database that can serve queries. But there's no compute functionality at that stage. Then you have a number of compute cells that live underneath that are more what you would recognize as a standalone Nova instance today. And the idea is that lets you build these things up to a certain limitation of kind of operational capability, and you can then aggregate more and more of those. It's kind of a scale-out model. Certainly worth looking at if you're looking to scale hugely. It's a great model. It replaces something called zones, which was the first attempt to do this. I think Chris, the chap that's working on it, has got some more work to contribute back in. Hopefully it'll make it Folsom. Another one that's worth looking for as you start to start stuff up, so there's a thing called host aggregates. In Essex, host aggregates were introduced as a way of saying, okay, this bunch of compute nodes have some certain properties that I want to be able to exploit. But the first model that came in was quite Zen specific and was particularly really focused around groups of machines that had a kind of shared storage layer. What's happening in Folsom is that's becoming a much more general mechanism. So you can decline servers to say, this set of servers, which may be an overlapping group with another, have certain properties, and then use the scheduler to exploit the fact as to where you want to place things. So the reason I call it as a scale factor is as you scale, you inevitably end up with not everything in your estate looking quite the same as you cycle things through. So host aggregates is worth bearing in mind if you're starting to look at those kind of capabilities. There are a bunch of things being done about manageability. One of the great things I found in the design summit this time was, whereas previously almost everything has been about features and new things to add and new ways of configuring VMs, I guess we're kind of getting to the end of things that we can do in that space, and there's a lot more people showing up saying these are things that I need to be able to manage the system. So 3 in particular that are going through. There are some deployability improvements, and included in here is a bunch of things that we've been working on to make things like the Nova services shut down cleanly. So a service is running a bunch of tasks. When you shut it down because you want to replace the software and rebuild it, the great thing is the control plane is independent. You can do that kind of upgrade. But you really would like it to finish the things that it's doing first rather than just stop partway through and give you a problem of a VM that's partly created. So there's a bunch of things being done in there to try to make just the deployability of it better. There are some things to be done to try to make the configuration a bit less spread out, so that the API configuration is in one place, you have a config file somewhere else, and to try to make some of those things more dynamic, so that if you do need to change some of your settings, that you don't have to actually stop and restart the service each time. So that's some good work. And as I said, there's a bunch more stuff being added to this notification framework, recognizing that this is a great way of getting insight into what's going on inside the system. There's another one that is kind of hovering on the edge because it's in the networking space, and with all the work being done to eventually move to quantum, which has started as a layer 2 product, is now getting layer 3 capability. There's a certain reticence to change much back in the Nova network manager as it stands. Well, there was a proposal that went up to use BGP, the Border Gateway Protocol, instead of ARP as a way of advertising where your addresses are. So each VM effectively gets pushed as a route. I think it's a really quite an interesting idea and quite a good way around getting around one of these problems. It seems to have sort of stalled at the moment in one of these kind of debates of, well, should we really be doing anything in that space or not? But I think it's certainly worth looking at, even to see some of the ideas that are in there on that. So those are the things that I think are good that are coming through in Folsom. How are we doing on time? Reasonably well. Questions? Rocks? Tomatoes?
Any questions? We can take
Sure.
a couple, I guess.
Pizza? Yeah.
In the space of identity management, has anything work been done to link in with things like LDAP or sort of IPA, free IPA in particular? Yeah, sort of.
So I don't know, to be honest. I know there's been a bunch of work on. So Keystone is this sort of central identification system that came in, and it became available with Diablo. In Folsom, the Nova's own authentication has been deprecated, so that will disappear. So you only have Keystone. So I guess if anything is being done, it will be being done out the back end of that. But to be honest, that's not an area of the architecture that I know that well.
There are two guys who are working on Keystone who are looking at integration with other systems like free IPA. They're not really in the stage of implementing anything, but they're talking about it on the mailing lists.
I mean, one of the things I think is good, useful parts about the way that the architecture is sort of built and things that need to be common are gradually being put into those components is, Keystone, as much as anything, defines the API that all of the other components are going to use. If you're providing something other than just a pure OpenStack blob of components, then it may well be that you implement something else behind that fits into your corporate authentication system or wherever to do things. So.
Just quickly following on, is there a plan to merge back in with the current state of Keystone in Folsom? Because at the moment the IP cloud is using a Keystone that's not very similar. So what's in front?
I believe we're compatible at the API level.
Yes, you
Right.
provide additional APIs as well.
We do. So some things we are contributing back, and some things that sit in there to kind of go into the kind of cloud space beyond the things that we're providing on top of it. So there are requirements part of it comes down to what sort of user, company, tenant type model do you want to have in here if you're trying to host for multiple enterprises and stuff. I think we've contributed a bunch of ideas back on things that need to be there. Some of it, I think, is going through into the next version, and some of it other people don't seem to want to the extent that we do.
Good. We probably need to wrap up there.
Cool.
So thank you very
Okay.
much, Bill.